Well, these three poster presentations come from my senior seminar, capstone in mathematics course. The students wrote a paper, did an oral presentation, and then after that did the poster presentation. Interesting thing about the poster presentation, that is to a completely different audience. It's to a general audience, whereas their papers were written to people who knew the subject. They each solved the problem which I created. This first one here has to do with insurance premiums, and we're talking about life insurance premiums. I gave her a set of assumptions to work with. She had to use my assumptions as opposed to real life data. So she was assuming that the mortality rate of 30-year-olds was 0.1%, and then it increased over time to 2% for 70-year-olds. So the question is, what is the premium you must charge in order for the insurance company to, on average, make a profit? The answer is surprising, because it's much larger than you would expect, but what she does here is she defines all her terms she needs prior to doing a little Excel chart of the computation. So first we talk about mortality rates, survival rates, what's the probability of surviving to a particular age, multiply it times the premium that would have been charged, and what she gets is that the insurance company would have to charge somewhere in the order of $6,000 in order to make a profit on this, which is really high, but she didn't blink. I mean, she did solve the problem that I defined, and what she did to enhance the problem is actually talk to an actuary who was a graduate of our college about why it's so wrong, and she did a little bit to enhance it, but not an awful lot, I would say. I mean, basically, the important thing is that she solved the problem. It is correct given the assumptions. For this one, the problem is one where you might say, who cares? But the important thing is that she solved it, and she used material that she learned previously to solve it. The problem is very simple. You have a set of stones, numbered 0 to 10. You start somewhere in the middle, and every single time you flip a coin to decide which way you're going to move. What's the probability that you'll get to stone 10 prior to getting to stone 0, or vice versa? Right? The important thing is that she recognizes how to model this, and that's the key thing. She models it correctly using what are called Markov chains. Markov chains can be modeled using matrices, and once you get the original matrices, this right here really is the crux of the problem. Getting this, the rest of it's kind of mechanical. Then she is asked to generalize the problem. She does, but she doesn't really quite do the general calculations. These calculations are correct, her terms are correct, her model is correct, but I think she could have done a better job with generalizing the problem and show how the calculations would actually work in general. But that, I think, may be my fault, because she really solved the problem that I gave her, and then her imagination didn't allow her to sort of enhance it the way I would have if I were publishing a paper. But it's, now, looking at this, you can see why I saved this one for the class, because this is a far more technical thing. What she did was prove the central limit theorem, only I didn't phrase it that way. She had to figure out that that was what she was doing. She went to a number of books and websites, and these calculations, some of them are copied, but they're cited. The important thing about the poster presentation, in this case, is that she did a presentation in class, and it was a good presentation, and it was clear to me that she understood. Right? The poster presentation makes her try to explain all this jibber jabber to people who know virtually nothing about mathematics, and this woman did a very good job. I mean, all of this is correct. The details are just enough to solve the problem and to prove that the problem is solved. What she could have done to improve this is to define her terms a little bit better, because unlike the other two posters here, the terms here are far more technical. The whole process is far more technical. For instance, here's the word moment generating function. I'm not entirely sure people understood what that meant. She did, and it was clear to me she did. But again, the poster presentation made her talk to people and just basically explain to laymen how they're doing. So the whole process, all three steps, I think were really important. To me, the important thing was the oral presentation, but the paper had made them clarify and know for sure they had solved the problem, and now the poster presentation is communicating to a wider audience. Not everybody in my class did the poster presentation. I wish they all had, because it was an interesting experience for all of them.